Today we have an exciting video for you. We're going to be talking about looping, specifically the while loop and the do while loop in x86 assembly. We'll be doing this, I'll say in the BIOS framework because that's what we'll be testing it with is that QEMU emulator that we have been using for the rest of the BIOS videos. And if you don't recognize some of the things we're doing, like displaying characters on the screen and setting up the display and some of the other magic numbers that we have, please do consider watching some of the other videos that we have for setting things onto the display and for the other magic numbers that you'll see. Anyway, while I'm thinking about it, if you do like these videos on this channel, please do consider subscribing. It lets more people be able to find these videos. So that's always exciting. And also, if you like this content specifically of x86 programming, please like it, and it lets me know to make these more frequently. So let's get into it. Here is our framework that we have for BIOS programming, and we're going to set up our display to mode 3. Again, if you don't recognize any of this stuff, please do watch some of our displaying Hello World and things like that videos. Next, what we need is a label, and we're going to jump to that label. Now, everything that happens in between these two spots will happen ad infinitum forever. And to prove it, let's set our ability to display characters up, and we will display the character R, showing that it is indeed running. Call int10h, and some of you aficionados will notice that this is not the most efficient code ever because each time we run the loop, it's setting up our ability to display characters and the character. We could just as easily do it up here because we don't actually need to set it to the letter R over and over. However, I think that we're not going to get hit on that many processing cycles. It's going to be still very quick. And I think that this also might illustrate for your first time through of what's actually happening and what we're trying to accomplish. And what did they say? Something about optimization is the root of all evil, or premature optimization is the root of all evil in programming. Normally, I'd argue with that. However, in the case of this, for clarity reasons, I do agree with it. So, enough chit chat. Let's actually run this. I'm going to make it and run it right away. And there we go. You can see how it's flickering. It is continuing to run over and over and over. So that is good. Well, let's make it a little bit more sophisticated because this is the equivalent of while true, which means that this thing is never going to stop running, at least while true in C++. And higher level languages, I'm assuming you can still use true. But anyway, that should be a good enough comparison for all of you programmers out there. Anyway, when you have a while true loop, what do you have to do? Well, you have to do the equivalent of breaking out of that loop. So let's first get user input. I think that that's something that is fluid enough that it will allow us to control the program externally here. So getting user input, you set AH to 00 and you call interrupt 16. Now, if you're wondering what this resource is that I'm using, it is sudo cpp.github.io. It is this channel's website. It follows along, roughly speaking, with all of the videos that we have here. We're currently doing the get key instructions, and then there's also various tables. And one of them we'll look at actually is the key code table. So let's do this first. Set AH to 00 and or 0 hexadecimal, and then call int16. And this is a case where if we would have overly optimized, we would have shot ourselves in the foot because A is obviously changing, so we would need to reset these things. So I guess there is something about that premature optimization thing. Anyway, let's run this once. And you can see there's the letter R. Now, notice it's not checking if we pressed a key and then if we didn't, it continues on. It actually does wait for us. And if I press keys on the keyboard, it just gives us the letter R over and over, which is because this loop never ends. So let's actually break out of it. To do that, AH and AL are stored with values after this function is called. If we go to our key codes table, which I already have up here, and you can find it here, it's all over the place. You can see that this is the key that they pressed. AH will be the high bytes, so this is the value that will be stored in AH, this is AL, and this is for a normal one. Now if you did Shift Enter, it would give you this set of things. If you did Control Enter or Alt Enter or other things, you have to even check if some of these exist because some of them don't. But anyway, this is where you can find out what numbers you should be seeing. So if we look at the Enter key, we can see that the high byte is 1C, the low byte is 0D. So let's use that 1C. Set AH, or compare AH to 01C. So this is the test for Enter key. If that is true, we're going to jump if it equals one another, and we will jump to a breakout label, which doesn't exist yet. And now that our program actually can terminate, we probably should clear our interrupt flag and halt the processor. Otherwise, it will just go on to oblivion and start running code that it should not be running, stuff out in random memory. Now, also on our breakout, let's display the letter Q, showing that we have quit out of our loop. And let's run this once. So I have the letter R, and as I press keys, I keep getting R's. Now let's hit Enter, we get a Q. As I press more keys, nothing happens because the program has terminated. All right, so this is a while true loop. Now let's look at a do while loop. And this is actually very similar. We don't need to break out anymore because we will actually be doing do, and then down here is where our while, I should keep that semicolon in there, while key is not equal to enter. Obviously this is pseudocode there. To do this, it's pretty simple. We get rid of our jump no matter what label, and it's probably worth back tabbing this over so that we can kind of follow along with our eyes. What we're going to do is if it's not equal to enter, we are going to run it again. So what will happen in this case is we are going to do all of this. If it's not enter, it will jump back up. If it is enter, it will not do anything and it'll just carry on through the rest of the program and go down here and do the things that it's expecting to do here. So let's prove that that works as well. So we have R's, and if we hit enter, we get a Q. So there we go. We have covered while loops and do while loops. If you would like to continue on with your assembly journey, we do look forward to seeing you in future videos. And that's all that I have for you today. So we will see you then.